In this video, we will understand what is resistance impedance of the sound wave or for the sound wave, and how it is overcome by the transformer action of the middle ear. The purpose of that middle ear is to overcome the resistance offered by so many structures. So resistance is nothing but obstacle for the passage of something. That something can be light energy, sound energy, it can be for anything. If you throw a water on the land, the water don't go further because the land will offer, the ground will offer resistance. Like that, when the sound wave reaches the pinna, it offers so much of resistance. That is number one, the pinna, next external auditory canal, next tympanic membrane, tympanic cavity, the malleus, incus and stapes, the ossicles itself, then the cochlea, then the liquid within that endolymph. So see, so many structures offer the resistance before the sound wave reaches the organ of Corti, which is the receptor for hearing. To overcome this, the nature has provided some modification in the ear. So that modification, to understand that, you have to know what is transformer. You must have seen some high tension wire like this. These high tension wires have got higher voltage. In front of your home there will be a light pole like this. It will have low voltage. So what happens from high voltage to low voltage? There will be a transformer. Okay, next to every area there will be some transformer box will be there. This is for light energy. Like that, here we want the sound energy to be amplified or increased. Otherwise what will happen? Before the sound reaches the inner ear, the sound energy is going to die and everybody in this world will be deaf. Okay, to overcome that, nature has provided some modification within the middle ear. That is what we are learning in this video, and that middle ear modification is called as transformer action of the middle ear. So the transformer action of the middle ear is contributed initially by this tympanic membrane. Tympanic membrane is located at the junction between external auditory canal and the tympanic cavity, within the lateral wall of tympanic cavity or the middle ear cavity. It is obliquely inclined, making an angle of 55 degree with the floor of the external auditory canal, that is allowing the sound waves to enter the middle ear. Tympanic membrane is set into vibration. The important point here to note is the surface area of tympanic membrane is approximately 50 to 55 millimeter square or square millimeter, whereas the surface area of the footplate of stapes is extremely small. Stapes, footplates is extremely small. It's just 3 millimeter square. So the surface area of tympanic membrane is extremely large, 50 millimeter square, and surface area of footplate of stapes is hardly 3 millimeter square. So the malleus, incus and stapes intentionally are not drawn in the above diagram. You will understand why. Okay, we are considering only the surface area of this tympanic membrane and the surface area of footplate of stapes. Only these two things we are considering. Nearly 17 times amplification of the sound wave will be there because of this surface area difference between the tympanic membrane and the footplate of stapes. So this amplification is necessary to overcome the resistance offered by so many structures traveling through the different parts of the external, middle and inner ear. So to understand this better, I will give you one contextual example. If you take a pen or pencil and try to hit to the wall, will it enter the wall? I don't think so, because the pen or the pencil is uniformly placed. The dimensions are always rectangular. Either the pen or pencil will break or your hand will break if you try to poke it into the wall. But consider the nail like this. When the nail initially is like this, if you take a hammer and just smash on this head of the nail, the tip of the nail will definitely enter the wall. That is because of the surface area difference between the head of the nail here and the tip of the nail here. So if you consider the same thing here with respect to our middle ear, the surface area of tympanic membrane is 50 square millimeter, while that of the footplate of stapes is hardly 3 millimeter square. It will resemble the nail. Please see this. See, that's why I told you this diagram I have written. So this one is the head of the nail, the tympanic membrane, and this is the tip of the nail, the footplate of the stapes. So head of the nail, when it is hit, the footplate of stapes will go inside where inside our oval window of the inner ear, like a piston, it will go inside. Okay, so that is the importance of this contextual example. That is a nail which goes into the wall. So the force which is hit over here, the head of the nail, will be 17 times more at this level, at the tip of the nail. So that is amplification of the energy, mechanical energy. Here it is sound energy. 17 times amplification is there from the surface area of tympanic membrane to the surface area of footplate of stapes, because tympanic membrane is much wider, 50 square millimeter, and footplate of stape is hardly 3 millimeter square. Moving on to the second contribution for the amplification of sound wave, or the overcoming resistance or matching the impedance, any words we can use, that is called the lever action of the ossicles. So what is this lever, L-E-V-E-R, lever action of the ossicles? The handle of the malleus is approximately 1.3 times longer than the incus. So when it is longer than the incus, it will amplify the sound wave by 2 to 3 times. This piston, this tapes will go in and out of the cochlea like a piston, creating a wave in the endolymph because of this action called lever action of the ossicles. The handle of malleus is 1.3 times longer than that of the incus. Please remember this point. Again, one contextual example I would like to give. See here, a 100 kilogram weight rock will be there. Can we lift it with a small rod here like this? I don't think so. Even if the rod is extremely strong also, it can't be lifted. But imagine one long rod. It's hardly 1 kilo, but it's really long and very strong rod. We take one tiny stone for leverage and we just poke it. This rock can be easily shifted, though it's 100 kilo. This long rod what we are using here in this contextual example is the handle of malleus. The handle of malleus acts like the rod. Okay, the incus is been used and the stone which is pulled inside is the stapes. Okay, so the lever action is there here, where the handle of malleus is longer than that of the incus, 1.3 times longer. So it amplifies the sound wave 2 to 3 times. So total amplification by the middle ear, number 1, by the tympanic membrane, surface area difference, it is 17 times. Okay, by the tympanic membrane and footplate of stapes difference. Second, by the lever action, 2 to 3 times, we'll consider 3 times. So total amplification of the sound wave is nearly 20 times. The sound wave has been amplified in your middle ear cavity. This amplification is not exactly what you think it is. That is, if the 100 decibel sound wave is coming here into 20, it will become 2000 decibels here. Don't think like that. It will not become 2000 level, because so much of resistance is there down the line from the pinna, external auditory canal, tympanic membrane, ossicles, tympanic cavity, cochlea, endolymph. So all this amplification is counteracted by that resistance. So it will be minus 1800. So 100 decibel sound wave is coming, hardly it will become 2x, 200 decibels ultimately at the level of organ of Corti. So this purpose of the middle ear amplification purpose is to match the resistance. So this terminology can also be used. It's called impedance matching of the middle ear. So the transformer action of the middle ear can also be called as impedance matching action of the middle ear or amplification action of the middle ear. All means one and the same. It amplifies the sound wave 20 times because of the surface area difference between the tympanic membrane and the footplate of stapes. Also 3 times amplification will be there by the handle of malleus is 1.3 times longer than that of the incus, causing lever action, amplifying the sound wave 3 times. So 17 plus 3 is equal to 20 times. But this 20 time amplification won't reach the inner ear as such, because it is used up to match the resistance offered by so many structures. Therefore it is better called as impedance matching. The amplification of sound wave is to match the resistance offered, so therefore it's called as impedance matching. This is called the transformer action of the middle ear. I hope this video helps in your learning process. Kindly like the video, share this video with your other friends, and save this video for your future reference. Thank you. Good day.